Hey guys, my name is Champomata, aka the Math Guru, and today I'm going to be giving a talk on a very interesting topic in pure and applied mathematics, that is Calculus 5, EX and ln(x). Be sure to like, share and subscribe. So, this calculus deals mostly with a figure which is represented by e and is an irrational number, and e as a function is written like that, and this is about the value that we get. So what mathematicians realized is that whenever you integrate a given function like this, you're going to end up with x to the power 0 over 0, which is undefined. But then if you take that given function and add 1 and express everything to the said denominator, as long as you keep increasing the denominator, it goes as far as infinity, you are going to end up with a value that nears to this. So this is where we end up with the derivative of the function ln(x). So if we are to take a given function y equal to ln(x and we are to add increments to that, so we have y plus increment y equal to ln x plus increment x. So if we are to cross y over the equal sign, we know that increment y is going to be ln x plus increment x, and then we know that y is ln x, so we can directly replace. So increment y is equal to ln x plus increment x over x. So if we are to multiply throughout the equation by inverse of increment of x, so that we have a ratio of the two increments, we're going to have inverse of x ln x plus increment of x over x. So we know that according to the rule of logarithms, this is ln x plus increment x over x to the power inverse of increment x. So I'm just going to go ahead and write it on the other side. So increment y over increment x is equal to ln x plus increment x over x to the power 1 over increment x. So ln we can break down this fraction into partial fractions, and we'll have 1 plus increment x over x to the power 1 over increment x. So we're going to compare this function to that one. So here we have a 1, as well as there we have a 1, so we'll compare this to that. So we have increment x over x equal to 1 over t. So which means if we are also to get if we are to make the inverse of the increment the subject of the formula, we're going to have t over x. And if we go back and replace this in our already existing equation, we have ln 1 plus 1 over t to the power t over x. So this is that. So this is going to give us ln 1 plus 1 over t. So this is just the same as t multiplied by 1 over x, where this can come before everything by rules of logarithms. So we have ln 1 plus 1 over t to the power t. So we know that this, initially we said that it's equal to e. So if this gives us e, so then we're going to say 1 over x multiplied by ln e. So we know that according to the rules of logarithms, again, whenever we have two similar bases like ln, so we know there's already an invisible e here, e in base e. So this means 1, so that's equal to 1. So therefore we can also replace where we have the ratio, we can replace it with dy dx equal to 1 over x. So this will multiply by 1, so it will give us the same 1 over x.